If you're a developer, or honestly, anyone who spends a decent chunk of time wrestling with large language models, you already know the universal frustration. You spend all this time crafting the absolute perfect prompt. You finally get it running, and then the context just degrades. The AI seems brilliant one second and inexplicably completely wrong the next. Well, today, we're rethinking everything you thought you knew about LLMs by looking at a couple of frankly wild breakthroughs from early 2026. Okay, let's dive into this. We have all been there, wasting hours, sometimes literally days, trying to maintain coherence across a massive 200,000 token context window. You add more examples, you tweak your phrasing, and sure, sometimes it gets a little better, but then sometimes it mysteriously gets worse. It really makes you ask, why do these perfectly prompted models still fail so unpredictably? Well, this source we're analyzing today drops a harsh but necessary truth on us. Most of us have a fundamentally wrong mental model of what an LLM actually is. We constantly blame ourselves. We think, oh, I used a bad prompt, or I used the wrong phrasing. But the problem actually isn't your prompt. The problem is how we foundationally understand the architecture of these models in the first place. So, to really understand why LLMs are genius one moment and totally off the rails the next, we're going to look at two seemingly dumb, highly counterintuitive hacks that popped up in early 2026. These two totally distinct techniques accidentally pulled back the curtain on how AI truly functions under the hood. Right, so let's get into hack number one, the Ralph loop. Back in January 2026, a developer named Jeffrey Huntley published a technique that honestly sounded like an absolute joke. He called it the Ralph loop. Yeah, named after Ralph Wiggum, the famously oblivious cartoon kid, best known for cheerfully chuckling and saying, "I'm in danger." Ralph has literally zero clue what's going on around him, but he just keeps going without a second of self-doubt. And as it turns out, that is a brilliantly accurate analogy for an AI coding agent running in an infinite bash loop with a totally clean slate context. It carries zero memory forward, it is blissfully unaware of everything that came before it. Now, what's really interesting about this slide is just how brutally simple the execution is. Step 1, the agent reads a product requirements document and a progress file. Step 2, it writes the code, runs the checks, and commits the result straight to Git. And step 3, it completely wipes its memory, just a blank slate. The agent is treated purely as a stateless function. The state isn't crammed into the model's context window, it is completely externalized in Git. I know, this approach sounds incredibly naive, but it works flawlessly because it structurally avoids context degradation entirely. When an LLM's context window fills up, its performance just tanks. But Ralph Wiggum? He doesn't carry the weight of past failures, or half-formed reasoning, or blind alleys into a new situation. And neither does this agent. By relying on a stateless processing approach, this agent actually outperforms those massive, complex, long context memory models because it always starts fresh, looking only at the exact current state of the world. The loop is the hero here, not the model. Which brings us to hack number 2, prompt repetition. Let's see how this second technique builds on that idea of working with the model's actual architectural limits. This one was basically an accidental free lunch buried deep inside a Google research paper. The technique is called prompt repetition, and it is exactly what it sounds like. We aren't talking about clever paraphrasing, we aren't talking about adding a bunch of few-shot examples or using chain of thought. No, you literally copy and paste your exact prompt verbatim so it appears twice in the input. And the results are staggering. Just look at this number. On a standard list indexing task, which is basically asking an AI to find the 25th name in a list of 50, Gemini 2.0 Flashlight jumped from a 21% accuracy rate all the way to a 97% accuracy rate. Out of 70 different model task combinations they tested in the paper, 47 showed a statistically significant improvement, with exactly 0 cases of degraded performance. All of that just from saying the exact same thing twice. So why does this work? Well, it all comes down to architecture. Transformers are causal. They only look at what came before them. Imagine reading a really dense textbook page from left to right, but you aren't told what the exam question is until the very bottom of the page. You just read all that information without the anchor of knowing what actually mattered. That is exactly how an LLM processes your front-loaded context. All right, section 3, the paradigm shift. By repeating the prompt, you're basically giving those final question tokens a second pass, but this time with full awareness of everything that came before it. These two hacks completely shatter the myth of AI memory. The reality of LLM processing is harsh. They process left to right once. They have absolutely no actual memory between sessions. And crucially, their attention isn't uniform at all. Research shows they heavily overweight the beginning and the end of a prompt and systematically underweight the middle. So, a sprawling 200,000 token context window? That does not mean you have a rich, reliable context, and is brilliantly illustrates the really sharp architectural distinction between how developers approach these systems. On one side, you have the Ralph loop. It relies on being totally stateless, externalizing memory via Git, and simple pattern matching. On the other side, traditional chain-of-thought approaches rely on being highly stateful, using internal context memory and deep reasoning derivation. They're entirely different ways of treating the exact same AI. So the absolute core lesson here is this. Stop trying to make LLMs behave like humans. Treating an LLM like it's a brilliant human colleague who just needs a slightly better set of instructions, that's just going to lead you in circles. We have to start designing systems that actually compensate for what LLMs structurally cannot do on their own. That leads us right into Section 4, reasoning versus pattern matching. To design effectively, we need to understand the two very different modes that LLMs operate in, which depends entirely on the task you've given them. Just look at this comparison. If you're in pattern matching mode, like extracting data or writing a straightforward script, prompt repetition works incredibly well, and stateless looping absolutely shines. But if you're in reasoning mode, using models like Oka 3 or Gemini, thinking for complex math or deep logic, prompt repetition gives you zero gain. In reasoning mode, chain of thought is what actually works. A huge reason so much prompt engineering advice feels totally contradictory is because developers keep mixing these techniques across the wrong modes. Okay, finally, Section 5, designing better AI systems. Now that we really understand the underlying architecture, let's talk practical application. What are the takeaways for software developers and tech leaders? Well, here is your checklist for better AI systems. First, structure your question first, not last. And if you can't, repeat it at the end. Second, externalize your state. Use files or Git instead of just trusting a massive context window. Third, design for iteration. A slightly wrong agent running 20 times and actually learning from failure is going to be a perfectly prompted agent that only runs once. And finally, for sure, know your operating mode before you start. Ultimately, the real engineering in AI today, it doesn't happen in the prompt box. The real engineering happens in the scaffolding, the loops, the memory layers, and the external state management. As the author perfectly puts it, the model is the compute, the system is the product. Which leaves us with this final, lingering question to ask yourself the very next time you open up your code editor. Are you building for a human, or are you building for a stateless function? Let that dictate your entire architecture. Anyway, thank you so much for joining me on this explainer. If you found this breakdown helpful, please go ahead and hit that like button and be sure to subscribe for more deep dives into the fascinating mechanics of the tech world. See you next time.